Algebra I 12.2b, find the domain of a function. Now hopefully you watched 12.2a, but if you didn't, you can try following, and if you get confused, you can just go to the description of this video and click back to that one, okay? So we talked about how the domain is the input, it's the x value, it's the x coordinate, and how the range is the output, the y value, the y coordinate, it's the function of x. When an equation represents a function, and the domain, that's the x, remember? When the domain of the function, the x, isn't stated as one particular value, we assume that x is all real numbers. That'll make the equation true. The value of the function is a real number. So take a look at this. We've got the function of x equals 2x minus 5. We can plug in any one of these values for x and make the equation true. We can go into infinity in the negatives, and we can go into infinity with the positives. We've got negative 1, 0, 1, 2, 3. It could even be decimals. It could even be fractions, and it could make this true. So the domain x can be any real number, negative or positive. The domain of the function of x is all real numbers. Negatives, positives, fractions, decimals, okay? Remember, real numbers include all of those. So it doesn't equal just one particular number. It could be anything, and it would make that true. See? All right. If we've got g of x equals 1 divided by x minus 2, well, g of x isn't defined if x minus 2 is a 0, because we can't divide by 0, right? We can't have 2 minus 2 as the denominator, and x would equal 2 to make this happen. So x cannot equal 2. We can write the domain in set builder notation. We did that in chapter 9. We're now in chapter 12, and there'll be a link in this description if you want to review that. We write it in set builder notation as with set braces, and the set, that's what these braces mean, of all x such that, that's what the bar is, such that x is not equal to 2, okay? And that's our answer, that's our domain. So any other number would be fine, because we can have a negative denominator, right? We just can't have it equal 0. Let's look at this one. We've got h of x equals the square root of x plus 6. Well, we can't have a negative radicand, can we? We can do the square root of 0. Square root of 0 is 0. So this could be a negative 6 plus 6, and that would make the square root of 0, right? That's okay. We just can't have a negative, right? You can't do this. That's not allowed. What would make this a negative? Well, if this was a negative 7, right? If x were a negative 7, we'd end up with a negative 1. And we can't do that. We can't have a negative. So that means x has got to be negative 6 or bigger, right? So it isn't defined if it's less than a 0, because that makes the negative. So if x is bigger than or equal to negative 6, we'll be fine. So we write our domain in set builder notation with the set braces. The set, that's what the braces mean, of all x such that, that's what the bar is, such that x is greater than or equal to negative 6. So if x was the negative 6, it would make square root of 0. If x were a negative 5, then that would make square root of 1 when we add the 6. If x were a negative 4, that would make square root of 2. If x were a negative 3, that would make square root of 3. All of those are fine. It just can't be negative 7, because that would make a negative 1, right? Okay, let's look at this one. The function of x is 1 divided by x plus 3. Again, we can't have a denominator that's a 0. So x cannot equal a negative 3. If we have a negative 3 here, negative 3 plus 3 is a 0. We can't do that. So our domain can be anything else, because we can have negative and positive denominators, can't we? That's fine. We can have 1 over negative 1. So our domain is the set of all x such that x doesn't equal negative 3. See? That's the only one that's not allowed. Okay, now we've got g of x, and it's going to equal the square root of x plus 1. Well, again, this isn't defined if this is a negative. So what would make this a negative? If we had negative 1 plus 1, well, that would be 0. That's okay. But if we had negative 2, if x was a negative 2, then that would make this a negative 1, wouldn't it? So it can't be a negative 2. It doesn't work. We end up with a negative 1 as the radicand. No negatives are allowed underneath the radical symbol. So if it's negative 1 plus 1, that's 0. That's okay. So now x needs to be greater than or equal to negative 1. It just can't be negative 2. So we write our answer. The domain is the set of all x such that x is greater than or equal to negative 1. And then that will make that true. Okay? So remember that y is the range, the output, the y-coordinate, the function of x, and these only include values for x that make the equation true, okay? And follows the rules of no 0 in the denominator and no negatives under the radical sign, okay? So our next video is 12.2c, and we're going to actually graph functions. And if you want to link to any of the previous videos that we just did, if you're confused, it might be a good idea to go back and watch these real quick. Few minutes of your time and you'll be all caught up. It's easy. It's going to be a link to my Grade 8 Math playlist for functions. It's not the full Grade 8 Math playlist, just the function part, because my Grade 8 Math playlist is different than this Algebra 1 playlist. This one you're in right now is all Algebra 1, but the Grade 8 Math one covers Algebra 1, geometry, statistics, and the Algebra 1 does talk about functions in here, which might be helpful to you because I might explain it a different way. But I go into deeper detail in the playlist we're in right now. The Grade 8 Math one just lightly touches over some of the topics, okay? But it still might be helpful, so you might want to click on that. There's about a dozen or so videos in there about functions, okay? All right, let's try graphing these guys, and I'll see you next video. Keep your chin up. Bye.